And we're live. Okay, so where we left off, we had this fun little number where we drew circles and we collided them or intersected them, and and got the arrow thing working. So we have these lovely arrows. Your arrows facing the right direction?
Oh, no, they're not. I guess I didn't fix that.
Let's finish up our arrows real quick. Let's synchronize these files.
Sure, I think that's line batch. So arrow.
Yeah, it's like we've got some junk code here.
Oh, yeah, we were talking about angles, and I prematurely made an angle method. I don't need that. And
yeah, I think
this is
stick to that.
Wait, negative, positive, negative.
Yeah,
negative.
I'll get rid of it. We covered that. We can go and look at the video if we need it. I'm just gonna change that back to what it was, so we're matching.
I remember, like, I've got pluses everywhere here because we've moved that to the vectors. So
that's probably, yeah, that could well be why yours were backwards. Let's see what happens there. That looks pretty reasonable to me.
Yeah, oh, maybe. Well,
how's yours?
I build errors. Oh,
Oops.
because you know why? Because I made that.
Oh yeah, you made the angle
one.
Yeah,
and then I didn't.
Yeah.
There we go. Should be good. No, I'll just double check. But yeah, we should be fine. Oops. No arrow.
You might need to change the line method to an arrow call.
Perhaps. Yeah.
Or yeah, delete the. Yeah, that's fine. Got this under control. No worries. Sweet.
All right.
Good enough. Let's I must say I thought the angled arrows were very aesthetically pleasing. We can fiddle with aesthetics later. So today we are going to do. Remember we started last time with this diagram. We had like a circle and a circle, and we like drew an axis between them, and we were talking about how, if you've got a circle and you draw an axis between them, if they overlap on that axis, we know that they're intersecting. But if on every axis, so if you check every axis and you find that there's an axis that separates them, that's the separating axis theorem, they're not intersecting. But the thing is, sort of conceptually you have to test every single axis, but we know we can like reduce the number of axes to a very small number by knowing things about the shapes that we're testing. So for the circle case, there's only a single axis that we need to look at, which is this one that is between the two centers, because that like that axis has no more information, and that axis has certainly no information, because it's like, well, they're both overlapping that segment. So what we're going to basically be doing is drawing a series of diagrams in our little project thingy here. Where's my notes? So we're basically going to build up to doing the separating axis thing in a series of steps by drawing diagrams. So we're going to be working in the draw method, and so the first diagram we want to draw is this one. So we want to have two circles, and if we have two circles, we want to draw the axis between them. And I mean, I've drawn a dotted line, but we're probably going to be like like something like a nice gray line or something in our thing. So let's head back to the draw method, and I'll start us off. Let's see, if greater than or equals 2. So if we have two circles, we want to do this. So we're not going to do it for every circle pair because it's going to get messy. So we're just going to do it for the first two circles. So we have A equals 0 and circle 1. So that's how we're going to start. And now it's over to you. So the first step is drawing that axis between the two circles. And so let's see how much you remember.
Alright, well, I get to think for a bit while I cut this code here.
No worries.
Am I not just gonna draw a line between the
Well, that's probably a good start. I'm also going to comment out this arrow too, because otherwise the diagram will get messy.
If I have more than one, I'll grab the first two. Sure. That'd be all of what you were saying, but that's all I caught.
Well, I mean, we need to start somewhere, so...
That's not it.
Well, mine didn't
I don't have the edit in. I don't have the edit in continued trick, so
mine didn't do shit. I'm just like, what have I done wrong?
yours looks the same as mine.
It does. Like you've got a line at least drawing. I'm like, what have I done?
Can't see anything wrong with that. That's the same code as me.
That's weird. Like I would have expected it to actually draw something. Oh, what's going on here? Oh,
it's the same blue.
That's not good. What the heck is going on there? Can you see that?
Yeah. Basically, the line is being the GPU saying it's too narrow.
I know why. I've made a terrible error because I've used zoom amount as we know. Zoom level, which is totally wrong.
Oh, right. Because we have that fancy method now, or the property.
So okay, that works now. You, on the other hand, have a bug.
Yeah.
So it's time for debugging. Let's figure out the bug. First thing to do might be just comment out this line so you don't have like excess stuff, and then circle A and circle B. Dot position. You'd think that would be fairly straightforward.
Yeah. Oh.
I mean that works.
Oh. Oh, now it works.
Oh, were you just like clicking up on the title bar or something and just getting like a stray circle as your first circle?
Anyway, doesn't matter.
Well,
it does the thing.
Works now. Okay, so
that's not really helping though. Now, can you maybe just restate? It's possible I was in and out of consciousness just now. So
okay. Well, there's so far as a good first good start. So what we really want, I'm gonna redraw this so we got a bit more clarity about what we're doing. So we've got two circles. Let's say they are, well, for now they're not intersecting. I get really good at drawing circles after all of this. So we have a line. So what we have now is we've got a big ass blue line like this. So let's change that now. And there's method to this particular bit of madness. Let's change that to a thin grey line that runs like all the way through. Yeah. So it doesn't really matter where it ends. Just let's run it all the way through and then some. So.
All right. Well, maybe just why don't I take this out, bar it, and I'll take this out, bar that, and then I'm gonna basically remove let's say this.
Before you get too far into this, might I suggest you use the variable names a and b rather than x and y, because that will otherwise get very confusing very quickly.
No problem. Oh wait, so this. Oh, it's a vector. Radius is a vector. Oh no. What I wanted is x. And then e, I'll just add it. Yeah, that's terrible.
Okay.
Didn't quite work out how I wanted.
Well, let's talk
you
about.
wanted a thin green line.
Oh, yes. So change that
Easy
gray. Let's make it nice and thin. That bit's easy. So let's talk about what's going on here. So first of all, using. Okay, now try them lined up horizontally. Sorry, vertically, yes.
I don't want to. Don't make me. Because I already know what my mistake is. It's kind of cool, though. Yeah.
Nifty. So
right.
You probably almost never want to do this business here with modifying like these. It's like if you're coding, you're like, I want vector A. You don't really want to have vector A changing halfway through your method. So typically it would be better to be like, A modified, or like A foo equals, what you've got there is like minus new vector 2, and you change the X. So
well, I mean, we don't really need a variable anyway. Is it better to just call it like A start and just new it up, or do you want me to?
Well, now there's a reason I was saying. Well, I mean, yeah, new it up. Yeah, that's exactly right. So the reason you want A and B is just so it's like, well, there's A and there's B, and they're constant. Have you read the stuff about where like it's sort of a standardish coding thing? Basically, the idea that you don't want to make mutable structs, you want immutable structs.
Yeah, I mean, I know that's a goal always.
So that's
okay, so you want me to new it up. Okay, I get it. It's more verbose, but it's more correct.
Yeah, it's not something you like. If you're doing standard C# programming, that's like a rule that you almost always want to follow. Whereas when you're game programming, it's like, I want performance, and no matter what, so I'm gonna mutate structs and whatever. But it's always it's like a useful tool to have in mind that that's a thing you might do.
Yes.
Alright, let's watch this again and see what happens when you do that. Yeah.
Right. I hadn't even solved that problem yet. I was just fixing this part. Right. So,
well, let's have a little look back, because I mean this is why I did spend so much time on it last time. Back at our arrow drawer method. So you'll recall we created this pair of basis vectors that let us work in this like new coordinate system. So rather than
yes, yeah.
Yeah. So rather than having like X and Y, where if we're off here and we're like trying to work on this circle, we've got our I and J coordinates, or in that case it was normal and perpendicular. And this pair of coordinates may well come in handy later on. So probably useful to have those. But what that means is, if we're like, I want to add the radius times 2 on the x, that takes me out there. Well, that's no good because that's like there. Whereas if I want to add the radius on that times n, it's like out that way. So hopefully that makes sense.
I just keep forgetting that we're in two different. We have to make that translation to different coordinate system each time.
Yeah. So
these aren't probably bad. I just have to now take them and normalize them.
Okay. So what have we got? We've copied these from there. That's probably a good thing. Yeah. Usually it's a bad sign if you're doing vector maths and you're starting to like modify the components individually.
Yeah, I think I know what you mean. I'm not gonna probably screw up getting to the right answer, but I mean,
no, that's all right. That's this is why you're doing it. So you make those screw ups. It's like, that doesn't work.
Yeah, but I'm still doing it here in the previous world space. Before that's not gonna do it. That's not gonna come close. But I need the A hat, B hat of these two positions, and then so that I can add and subtract respectively from them.
Well, okay. Let me tell you this. What you have correct is, you want negative radius times 2 and positive radius times 2, and you want to stick those on the end. That's right. That's sort of where we're going with it. Everything else there is wrong. So you can probably get rid of these because these A start and end, B end are kind of meaningless. Certainly the contents of them, what you're setting them to. You were down the right track when you copied these.
Yeah, I know I don't need the perp part of it. It's just okay. You know what? I'm gonna grab this whole thing.
Go for it.
Doctor it. So I think so what happens here is I definitely want I want to normalize the axis that I'm on so that I can draw it, and then after that I just want to decide how long it is and where it starts.
Mm-hmm.
So the first part is like b minus a gives me my axis hat, and then I don't need top or bottom. We are gonna draw a line. If I go from now, I have to add and subtract these radii from the hell.
Take your time and have a good think about it.
Well, I feel good about n. Now I need to multiply n in here. Well, yeah, both of them need to have some influence with n because I'm gonna draw it behind it, or
now
remove some, and I'm gonna
so some. Multiply by n. Now keep in mind that n is a vector. So multiplying by a vector is not necessarily the operation that you want. You'll notice it's not on the cheat sheet, for example.
Yeah, you're right. Yeah, I don't want the y.
Although there is a multiply by n in the cheat sheet actually. You have to multiply a scalar by an n. I should probably bring the cheat sheet up so everyone can see. So this one here, vector scaling.
Yeah.
N in this case being v for vector. You can scale that vector up and down to make it longer and shorter.
Yeah, and this is exactly what we want to do.
So that's sounding pretty good to me.
So I'm gonna call it v, but yeah, I want to take this axis and draw it. I want to I want to start it. That's the only thing that bothers me is I want to subtract from the start. I'm getting hung up on that because, well, it's just multiplying it by it's like some negative value, which is gonna have something to do with the radius. Like this is involved somewhere. Maybe I'll just sorry.
No, take your time. Yeah, it is useful to think about. Subtraction is really addition of the number of a negative number, or it's like you're multiplying that number by -1 and then adding it. So
yeah. So this, I mean, the vectors scaling. I'm gonna scale the start by something. Or in this case, start is A, so scale A by A is a vector and R is a vector, or is it A plus? Oh goddamn it! I just swore, sort of. A times I only want that one component though. I hate this newing up thing, but I need. Well, you don't want me to modify the components of the vector, right?
Yeah, that's definitely the wrong road to take.
Yeah. Well, what else do I have other than B?
You can see my diagram I've drawn here.
Yeah, so that your n is my v, so I'll just make v n again.
Oh yeah.
Yeah, so I have n, and I want to multiply it by. I want to scale. I want to do vector scaling on both a and b. And get the gray line. This is where do I put the r without,
Take a quick gander at the bottom left diagram on the cheat sheet. I should really upload this for people, even though it's not finished. But you'll see.
Scale a normalized vector to get a vector of particular length. Oh shit! Right.
So that one,
Vector 2.
we will do a lot of.
Yeah. So okay. So I want the length. Wait, what happened? Yeah, length. The length squared because we don't want to do the mathy poo thing. Oh, wait. Okay. What if I have to make a new vector with the length of?
Tell you what, your last line there, where you're actually drawing the line, is so close. It's so close to being right.
Well, it's just in the wrong component world because A is a vector, N is a vector, and R is not.
R is a scalar, yes. So
yeah. So it's either I got to lengthify the A and the N, but that's not going to give me this is supposed to be a vector, so I need to end with a vector to get a start and a finish. So, but well, R is what I want to I want to apply it to the X axis, and you won't let me.
Well, let's have a little think about this picture over here. So let's think about what we're trying to do. We're trying to get this point here. Well, sorry. Can I have my paintbrush back, please? We're trying to get this point here. So this is like B dash. Mm-hmm. We're trying to get this point here. So the question is, how do you get to that point? Maybe try and describe how you would get there.
Well, I mean, my original idea was just to start from B and add 2 radiuses of B.
You were adding to the X, so you were going to end out here. So sort of should probably draw this to scale.
Well, n times. Well, in this case, it's n times the radius times 2, where n times 2 are.
That sounds pretty good to me.
Right. But n is still not, n is a vector still, and 2r is not still. I mean, I guess I could do 0 on the y
Well,
and vectorize that.
let's talk about what you were just about to do here, because when you were adding, you recall our basis vector discussion. When you're adding stuff to the x-axis, it's equivalent to doing, 1, 2. If you say b dot x plus 2r, that's the same. Actually, yeah, hang on. Wait, what? Okay, bx assign bx plus 2r. That's the same as saying I want the vector that is b plus, well, I guess it would be, yeah, you're adding the vector 2r on the x-axis and 0 on the y-axis.
Yeah.
Which is the equivalent of saying b, now this should look really familiar from last time, b plus 2r x hat, because x hat is 1, 0. So what we've done is b plus 2r times 1, 0.
Yeah, I just did that, I think.
Oh.
Yeah, I was doing that while you were.
Okay. Yeah.
I think that's closer.
So that's closer, because that's no, it's sort of the same. No, it is closer. It's closer. Not quite there yet, though.
No.
Because what you've done is over here, you're multiplying a vector times a vector, which is not an operation we've really discussed, and not one that you usually use.
Wait, sorry. Where am I? I didn't see your mouse point. Where am I doing?
Okay, so a plus something, that makes sense. That's the top of the cheat sheet. Vector addition. N is a vector times another vector. Vector times vector is not a thing we've really talked about, and is not a thing you really often do.
Right, but I see. Yeah. So I'm looking at that going, yeah, I want to get the like b plus 2r 1, 0, and this is.
So
I see. Yeah.
Let's ignore that one for now. That's correct, but we'll ignore it, because this one here is the one that you really, really care about, because that's what you're doing.
Yeah.
And the thing about that is you can change that slightly and get, like we did with the arrow, you can you can change the basis vector.
Mm-hmm. Well, okay. What I know this part is, this is x hat, and
that's x hat, and n you've got there is n hat. So what you've written is like a plus n hat times x hat, and it's like, well, okay, that's a plus, blah blah times 1, 0. That is not a sensible operation. If you recall when we talked about matrices, you can treat vectors as matrices, and one of the things about it is they have to have, actually, it's like, yeah, the if you have a 1 by 2 matrix that you want to multiply by a 1 by 2 matrix, that doesn't make sense, because this one and this one have to match up. So
right, because they're jagged or whatever.
Yeah, because normally what you do is you'd have like a 2 by 1 matrix, and you'd have like that times that. That's not right. That times that, for example, and from that you get a 2 by 2 matrix, because you've got that and that. But 1 by 2 times 1 by 2 is not a thing you can actually do.
Okay.
So why don't we Why don't we try something? Well, let's see what we've got.
Well, see, I haven't. My problem is I haven't gotten close to. I haven't used n anywhere.
Okay,
So,
well, okay. Let's slow down a second. Let's try and reproduce this diagram. So we had the line from A to B. Let's draw two lines. So we've got this one here. Let's just draw that for funsies. And then we're going to try and draw the line from B to this point, okay? So we're going to break up our line. So let's just draw exactly what we've got already, which is that. And then we'll try and modify it to make it work. So what have we got? Okay, we've already got a line from A to B. Now we want a line from B to the thing that we've got there, which is B minus R times vector. Okay, yep. Okay, so I've seemed to have copied your code. So let's see if they match up. So now you've done y hat there on this one here, which is why it's going upwards.
oh, whoops. Yeah.
So I mean, let's like, even though it's wrong, we'll 1, 0 just to give you the idea of what's going on.
It went the other way.
Well, you're subtracting.
Yeah, because it's from that's just a holdover from the old code where I thought I had it right, and I basically pasted the y component, not the x one, in that start to
Okay,
finish.
well, this is fine. We've got something on the screen, which is always a good start. So
Kind of looks like your diagram.
it does. It's going across that much. Now we just need to get this to tilt up there. We just need to sort of rotate that around. So
I'll just multiply that by n.
well, what happens when you multiply? Let's try and multiply it by n, and we'll see what happens.
Okay. Easy test. Whack-a-mole.
So I can't believe that compiles.
Nothing.
Well, you'll notice that, nothing happens. What is n? Why? I'm just like, why
N is
that
the
work?
hat of what's supposed to be the real. I don't know if it's correct, but it's supposed to be the
Okay.
normalized. It's supposed to
So
be n hat.
let's have a look. We do, in fact, have multiplies the components of two vectors by each other, which is not really a thing that we want almost ever. So what is this doing? This is doing is, I forget the name of this thing. Is it the Hadamard product? I can't remember. So it's looking at this and it's like, well, we can't do a linear algebra operation on this. We can't turn that into a matrix thing. So what we're going to do is we're just going to go straight up multiply. If we have, a vector n that's made up of nx ny times the vector x and xy for funsies, it just creates the vector nx times x ny times ny. So it's doing that. Unfortunately for us, that doesn't actually mean anything.
Yeah. Okay, going back to the cheat sheet.
But because what ends up happening is in fact we can scribble on this in red. This is 1 and this is 0, so you're ending up with the vector nx 0. So you're still only going in the x direction, which is why it's still going out to the side. It's just going out a slightly different amount, probably slightly less. So you're ending up here.
Sweet. Okay. Well, I want to. Yeah. I mean, distance. Didn't we? We basically didn't we kind of do this yesterday when we drew the arrows?
Yep.
Um.
So I mean, we can go back. We'll have another look at this. Look at what is happening in this one. And maybe we could do a bit of a, I don't know what you call this. It's not a unit analysis, but come back to line batch and just go through and be like, n, that's a vector 2. P, that's a vector. Top is a vector. Bottom is a vector. Top.x is a scalar. Thickness is a scalar. Color is a color.
Oh, I thought I was avoiding. I could avoid x and y here.
Yes. So that's why it might have been a wee bit confusing, because we're kind of doing something. It's doing something actually a little bit more complicated in this arrow method. So let's literally just take a line here. I'm going to come back here. We don't actually care about anything but this section here. So let's analyze what we've got here. We've got vector plus so does and we can match those up. So n is a vector, top.x is a scalar, top.y is a scalar, p is a vector.
Yeah.
So what we've got down here is a vector that's kind of equivalent to our end. In fact, it literally is equivalent.
Yeah.
Plus a scalar times a vector times a vector.
Yeah, instead of a scalar times a vector plus a scalar times a vector.
Now keep in mind that this is going off in two different directions. Like, we actually don't care about p at the moment, because that's the vector that tells us oh, give me a pen. That's fine. I didn't need to draw anything. What's going on? Anyway, it gives us the vector in the perpendicular direction to n over here.
Yeah, to make that arrowhead. So
we don't actually want to go in that direction. We want to go only in the direction of n. So we can actually say, well, maybe our value for like y here, the up and down direction, that's going to be 0. So we can just zero that whole term out. So why don't we do that? Well, let's just be like top y is 0. 0 times p is 0. So we can just get rid of all of that. So now we're in a bit more of a useful position. And I'm going to try and figure out why I can't draw anymore. Oh, I know why. Got like this tiny little 2-pixel selection, and it's like, well, fill in that selection, are you? That's better. Okay. Ooh, this is new. Let's
who knows?
Let's see what we've got here. So b plus r times n.
Yeah.
That's looking pretty good. So, what we did is like, okay, we've got b.
Yep.
We're going to stick n there, but rather than n hat, we're going to multiply it by the radius and get, r times n. and we're going to end up here. So now we have this b dash. So let's finish up. Now we have that. Let's finish up by making the whole axis.
And I just have to switch the color back to dark gray.
Well, there's a few changes we can make at this point. One of them is, you'll notice if I make a tiny circle and like a big one, it doesn't quite work right because we actually have 2 radiuses rather than 1. So that's one thing to consider. And other than that, we can just turn it into like one line. It's like we've got A to that one, A to that. We may as well just grab that and make a single line. Well, we know.
Yeah. Okay, wait. I want to just get to the.
Yep. Okay.
Yeah, the radiuses are right, and then I'll get to the next. Whoa. Oh, that's right. The errant mouse clicks. You said you wanted to make this one line call, right? Oh, yeah, sure. Because now we don't need to draw it 3 times.
Yep.
A is this. B is this. Okay. Yikes.
I feel like something is wrong with mine. Oh, I know what's wrong with mine. It's like it's not long enough. I need more radius. And then I can make this thinner again. Now we've nailed that one. So that's looking pretty good. We've got our axis. Now, the thing to understand about our axis that we have here is that, this is going to become sort of, it's going to become important. Let's see. Okay. So this is going to become fairly important at some point, and that is our axis that we have is directional. It actually matters what direction we're traveling along that axis, because basically you could say that is different to that if we had it in the opposite order. So we're going to stick an arrow there regardless, just so we know what direction we're in.
Why does it matter?
That will become apparent, but because we basically have to select. Well, we have to have a direction.
Okay.
And it's not so important that we know, like it doesn't matter what order we do this in. Like if we take the one that we place first, or the one we place second, or the one we have on the left, or the one that we have on the right. But it does matter that we're consistent. And it's gonna make life a hell of a lot easier down the road. So if we do that, we can see which circle we placed first. So this is something you're kind of going to have to trust me on.
Now what?
Okay. I was trying to figure out what you're doing. You've added another line.
Well, I wasn't sure. I didn't quite see the diagram. So
Oh, sorry. Yeah, we just needed the arrow. The extra line is not really necessary.
Well, you've got three lines being drawn. Oh, you didn't. I thought we were reducing the axis draw to a single line.
Yes. Yes. So the arrow I've just drawn between A and B.
Yeah, and oh, I get it. Yeah, you don't need the extra line because this is that line.
Yeah, the arrow comes with its own line. So
Fancy.
Now we can start talking about the separating axis theorem. So let's make a new layer for this exercise. Okay. So what we want to do, we're going to expand our diagram. So we've got a circle, and we've got a circle, and we've got this nice professional drawing of like this grey axis between them, and it's directional. So we actually know that we're going in that direction. And that's going to become important because what we're going to do is we're going to treat this axis as a single dimension. So what we're going to do is we're going to be like, right, what the best way to explain it is like, I think I talked about this before. We do projection, so it's like, if I have a whole lot of shapes there, and maybe a blue one like there, if I squish these down onto a single dimension, it's going to look like, that, and like this one's going to be like there on that axis, and this one's going to be like there, and this blue one's going to be like there. And so if I'm thinking about this like a number line, it's like it's 1D. It's it looks like this, and there is no y-axis. There's only this x-axis, or our whatever we call this axis. But it's the important point is when we're thinking about what ranges these shapes cover, we're only thinking about it in one dimension. So we want to consider our circles. So we want to figure out what range these circles take up, because as you can see, when we take it down onto this one axis, we've got like, here's a circle and here's a circle. We can tell the green ones, they don't intersect because they've got a separation on this axis, whereas we can tell that the red and the green one do overlap, at least on that axis, and same for the blue and the red one here. So that's sort of in theory what we're going to do. But now that we've drawn this axis, we want to keep drawing on this axis. So we actually want to produce not this diagram, but basically this diagram. So what we're going to have to do is the same thing we were doing before. We've got our n, got our n hat. So we're going to figure out what areas these circles are covering on this axis, and then we're going to use our n hat and the technique we had before of like starting point plus like q times n hat to move up and down this axis, so we can actually draw it back into world space so we can produce this diagram. Does that make some amount of sense?
Yeah, I mean, yeah.
Good. So
sure.
Let's redraw the circles. This is the diagram we're going to make next, which is we have our axis with a direction. We want one circle, and say this first circle, we want to draw the range of that circle, and we have the other circle, we want to draw the range of this circle. And again, just to make things simple, we have a start and an end for these things, so we can actually give these a direction as well, and so we'll draw those with an arrow. So this is the diagram we're going to produce now. So let's start doing that. So I'll let you go programming for a bit and see what happens.
Cool. All right, I'll try to draw the red arrow first.
Mm-hmm.
So A minus R for A divided by 2, or I guess times 0.5. And then that's gonna end at A plus circle A. This times 0.5. I don't know. Let's see. Not quite. This is gonna be an arrow too, not a line. But I've cut it in half, so I need to just.
Yeah. So radius is obviously half the diameter. So.
Right.
We can make these ones a bit thicker too. So. Yeah, so we don't need that 0.5f.
Oh.
Let's see how that went.
And yeah, I need to make it. So I just need to arrowify it. It's not an arrow at the moment. Fine anyway.
That's the convenient thing about having that.
Looks okay. Other than the draw order, I know we have that black arrow.
Yeah,
Seems like I'd be drawing on top, but it didn't quite work that way.
Oh, your thickness is different.
Oh, yeah.
Like I've got a thin black one and a thick red one. Like I've got 2 to 8 is what I have for the widths. I think you might have modified the arrow head size there, which is the first of the 2 size parameters, arrow.
Yeah, 2, 2, 8, and then 10 for both.
Yeah.
Right, and then I'll do B. So that's just B, circle B, B, circle B. Everything else is the same, and it's blue.
That's looking pretty good to me.
What else? What am I missing here?
No, I mean you're basically right, but let's do this thing. You'll notice that I've offset them slightly because when we go and do like an intersection, like if we have that and that, it's like we want to actually see both of them here. So why don't we just offset them, one up and one down? And so now we're, you know, hopefully you're understanding the basis vector thing now. So it's like, well, which direction?
Yeah, let's not add to the y and subtract to the y, shall we?
Yeah. What direction do we want to move in?
Well, when we want 2 y hats, right? One y hat would be like 0, 1, and the other one would be 0, -1. And I'll stick those on.
Well, keep in mind that y hat is like that direction. That's y hat. We want to go in that direction.
Okay, perp 270.
Yeah, that's the spirit.
But yeah, but I just now I'm just trying to figure out where to put that because I don't want to add more drawing, so it needs to go in here somewhere, probably on the y-axis. Now n, we want to keep n because that's giving us our range, but we want to, I guess, add n, but I mean,
we've got 2 points here, 1 and 2, so we want to move them both up like that.
Yeah, right. So add, and then subtract.
Let's I was like,
this isn't right, but
no, but you recall we had this p here just to make that more convenient. There's a start because you can see that's offset very slightly.
yeah, let me go back to line batch and look at this again. Multiplied by p, not added.
Well, keep in mind our I'd go back to line batch and have a second look at that, because keep in mind the way that this works is you've got a top y as a scalar, so you actually do have an add here plus a scalar. You're scaling p, so this whole thing is a single term in the equation or the formula.
Right. Yeah. So I'm missing the scalar. Oh yeah, 'cause I'm missing the one, and I'm missing the n is just a unit, and so it doesn't have its own length. So I need to actually multiply this times something at the length that I want. Whatever. Hold on. I'm gonna clean this up a bit here. First of all.
Yeah. We'll put our p back. That oh, that was a funky little trick with the I'm assuming that's resharper.
Yep.
Nice.
Control RV and then auto. Press enter. Basically everything's enter. That way you can make terrible mistakes at warp speed. But yeah, sorry. So I'm missing. So we're back to, we don't want to add p because, or we don't. Yeah, well, p hasn't been scaled yet. So we need to scale p times. We need to scale p.
Well, let's think about this before we go scaling it. How far do we want to go? And the answer is probably like
vector 1 or unit 1 or unit x or whatever it is.
Well, let me quickly run this and have a look. We probably want to scale it by like the thickness of this line, and we know the thickness of the line.
Yeah, we do know. We do. Yeah. Okay, so I'll make a scalar for, well, thickness is the scalar. Fine.
I mean, you can
so
just.
We always want to add. I'm just trying to think about. We probably want to be like times the thickness, which is what. We'll just pull that out, I guess. 10.
It's 8. It's the next one.
Right.
But it's 8 divided by zoom.
The arrowhead. No, I don't know it's constant, so it's not a great thing. But I'm just thinking, like, okay, times thickness.
Well, before you go too far, the thickness is actually 8 divided by the zoom.
Yes.
So.
Right. I don't know.
That looks really good to me, and probably run it. That looks great, terrific. Yeah, sweet. Okay, so One thing I'm gonna sort of try and get you to do as a bit of a convention, because it is the mathematical convention, and that is usually and there's a reason for this. You go plus or minus the scalar times the vector, just as you would in sort of basic algebra. I'm not sure if you remember, you might have like a quadratic equation, for example. It would be like, what would it be? It would be like 2x plus 4x squared plus, it would be like 2x squared plus 4x plus 3. You put the scalar and then the variable. In the same token, you might, of course, you can square the damn thing, but and it
also makes it cleaner because they don't have to multiply by a negative. It's the
exactly. So and that's when you see a negative in an equation like this. If you let's drop that out and be like, if you saw that, it's like, all right, what's the coefficient? It's -4 in, the term is that, and the coefficient is -4.
I do remember that. That makes a lot more sense. And the multiplication's implied.
Yeah, exactly. And that's just convention that is followed by maths. So it's like we may as well follow it. So we're, it's easiest to follow other people's maths, and other people find it easy to follow our maths. And it's also, that's the mathematical convention, because for the most part, conventions in maths are useful. They're things that people have come up with that work well. Okay, so this is looking pretty good to me. This is looking actually really good. So?
It looks like our arrow sizes are not respecting.
No, they are. That's exactly why they're still that size. Because we can take those off, and we can demonstrate what happens if they don't respect zoom. We get like these lines, and then you zoom right in, and you get this massive arrowheads. Which, maybe you want, but I find this is more useful. Okay, so now we have this situation. Now you've kind of come at this a little bit backwards. It's probably actually good. The thing is, we have the diagram, but we actually need, now we have the diagram. What we actually need is this over here. We need the number line. We actually need, what is that value? Well, the green ones in this case are the circles. What is that value? What is that value? What is that value? What is that value? Those are scalars. So we need to extract out these values. That's actually fairly simple. Also, it means, what we've done here, we've generated this. We've gone like, all right, take minus the radius plus the radius times n minus the radius plus the radius to get our 4 points for these things in 2D space. We want these in 1D space, and we want them basically we have to decide where is 0. Like, is 0 here? Is 0 here? Is 0 here? Is 0 like out here? So we need a 0, and then we can say, right, 1 point is that far, 1 point is that far, 1 point is that far, 1 point is that far. Or, maybe we have 0 here. It's like that's that far, and that far. So this is why it's directional, because it's like, if this is 0, these are the negative numbers and these are the positive numbers.
Right.
So that's what we're going to do now. We're going to try and figure out where these numbers are. And we've got a really good head start because we've actually already drawn the diagram. So I'm just thinking, how am I going to start us off? I'm going to give you this bit. We're going to make this 0. Okay? This is going to be our 0 point. And
Is
so
that arbitrary, or is there a reason for it?
it makes life a lot simpler because it means you just say that this circle is at 0. Otherwise, you're saying like, I mean, and it would be equivalent to say this circle is at 0. But if we were to say 0 is like here, then this is at some unknown value, and this is also at some unknown value. So if you say that this one's at 0, it just saves a little bit of maths.
Right.
So
Okay.
let's start with the red circle first. So what we're going to say is the center of the red circle is at 0. Where is, now hopefully we haven't used, that's another reason why we haven't used the vector. We have float a start equals blah, float a end equals blah. And that's what we're trying to come up with. And that is equivalent to, if this is our circle A, it's that and that. So we want these two numbers, and then we want to redraw them as, the start and end point. So we actually already have these numbers in a sense. So I'm gonna leave it at that for now and let you try and figure out what start and end are going to be. And this is a wee bit tricky because we're not working in the diagram yet.
Okay. Oh.
So I mean, one way to think about it is, so that's going to be our 0. One way to think about it, and now we're just going to, do some really funky thing. We pretend if that's our number line. Now this is single dimensional. If that makes sense to you, does that make sense?
Yep.
Good. I will unrotate that. So away we go.
There. I guess I need to get back to the rotated one, right? I reverse the n-hattedness of everything.
Pretty much. Like, there's actually not that much in this. You can imagine, like, if we were going to draw this point here. Bear with me while I fix up the drawing canvas. If we're going to draw this point here, it's like 0 plus n hat times q. So this point is like, we know this is the end, so this is a end, I guess it would be subscript, so a end times n hat, and this is a start times n hat. So it's like, okay, solve for a, you have these equations already, so solve a start and a end. This is going to hopefully take 30 seconds because you literally have that.
Yeah. What I wanted to do is literally perp all the points down to the, like, just draw a line from A horizontal and then just like bring everything down. But that's from an old math thing. But yeah, I mean, okay, so a start times n hat, so I want to get rid of n hat, divide them both. This is a start here. No, it's not. That's
Well, keep in mind that we've defined 0, so whatever we do, we're adding to the position of that. So we can already get rid of, we can already ignore this a at the start here, because we're going from there, and the a at the start here because we have 2 points. and we can ignore the perpendicular because that's just for the sake of drawing the damn thing. So we can get rid of the whole thickness and perpendicular thing.
Yep.
So that just leaves us this n hat, and we know we don't want n hat because we are in like a vector space. So, and I mean, radius divided by a vector, that definitely doesn't make sense. There's no what you actually want. I'm just going to give you this. Just remove the divide by n, and you're done. Perfect.
Why?
So
Why?
Well, let's finish this off now. What we've basically done is said a start is that, so a plus a start, and then a end is this one, so a end. We basically just pulled out the radius.
Which makes sense in one dimension.
Exactly. So what we want now, and this is where it gets a little bit more interesting because we want this in the space of A. Like recall that 0 we've defined is going to be the center of A. So we want float B start equals something and float B end equals something. Now, what I'm going to do here, I'm going to take this line here. We've got our A start, A end. Yeah, so what we're going to do is we're in the space of A, so it's now B start and B end. And at the same time, I'm just going to switch the drawing style to our second line. So, pulling that out.
Catching up to you.
Yep, that's all right. So all I've done with the perpendicular is I've changed it from add thickness to subtract thickness, and I've changed the color to blue, just so it looks like our other line, because this is obviously going to be the B circle. So I mean, we can start with circle A radius and circle B radius. What do you have there? Yeah, we can start with that, and this is going to be wrong, but we'll just run it and see does it draw something, and you know it does. It draws the same thing as A. So we've got the you're just missing a minus on the thickness there. But yeah, so you can see that now we have the values for A. Let's get that arrow back onto the second circle, but now this time we're only manipulating it in one dimension. So we're working through, we're squeezing this through this like float and float rather than vector.
Okay, well, I want to. I mean, I'm multiply it by the hatness of one dimension. It's not n anymore. It's x hat. But that, I mean, no crap.
That's all right. What I will show you real quick is one thing we could do is this. What happens if we change those B start to B end to be the B radius? It's like you get that diagram, and you know that would be right if they were over the top of each other, like exactly.
Yeah, I'm just saying, like I want to move. I mean, I know where I want to put that.
Mm-hmm.
arrow, but it's almost like I need to like multiply it again by n to get it over there. But we're in 2 dimensions, so I don't. Or I mean, we're in 1 dimension now, so that's a lot of sense.
Mm-hmm.
Ah.
So I mean, we're in 1 dimension. Let's think about what we're trying to do. We have. Oh dear.
The thing that moves me from 0 to here is, I mean, because we're not actually even at 0. We're like 0 hasn't even come into it yet. I mean, well, B. I mean, just kind of just add B to it.
Well, B, unfortunately, is a 2-dimensional vector, but you're on the right track because if you recall back in, we'll draw our 2D space in pink, this arbitrary origin, the vector to there is A, and the vector to here is B.
Yeah, but that's just going back to going back to n hat to get B.
Kind of, but you're going sort of backwards is the thought. This is fairly elementary, so don't
Sure, that's why I can't figure it out.
No, but the point is don't overthink it. So ignore the circles, for example, for now. You want to get to B, and we're just going to add, obviously, the radius to get those 2 points. Mm-hmm. So the question is, how do you get B on this line? And so, any thoughts on that particular matter?
Well, I thought I'd already went through both of the ways I would do that. Multiply, like to actually put the point on that line, I'd use n hat to get there. But or just add the B position, but I can't because it's components. So,
so that's n hat. But we don't need n hat for this.
No, I get that. I mean, it's like just add the x of B to 0.
I mean, that's a good start. So adding the x of B to 0 would be, the x of B is this amount here. So it's that. So adding that to 0 would be like doing that. So not quite.
The length of B?
The length of B to 0 would be, that's kind of along the right track. It's that length of B is this vector here. And so the length of that vector, and you're on the right track by saying length, because it's length is actually a scalar property that's, still a reasonable thing to say, but that would take us out, there, because the length of B is relative to this origin. And the thing is, this origin is not useful to us as such, because you project the origin down onto this line, and maybe it's it's like here, this is just a meaningless point that we're not using. We've made our own origin, which is at A, so we have to think about things relative to the position of A.
But okay, well, we have A, but A isn't even really A doesn't really have anything to do with 0 other than we happen to know that A start, or AN minus A start, is probably 0, right? Or no, divided by 2 or whatever.
Well, what we've basically said is everything is relative to the position of A. So anything you do has to involve A somehow, because you're taking it away from this origin here. Like when we convert to 2D, we actually, what we'd rather is all of our positions be around A like that.
Okay. Can we add circle B to A start?
I mean, you can, but okay, circle
that's not going to get
B A start. So that would be that plus the radius of B. So that would actually take us like there.
Yeah. I'm drawing like I'm.
So let me give you a bit of a hint here. In fact, let me give you a nice whopping great hint. So coming back to our cheat sheet, at the very start we have this thing to find the vector between 2 points B. Subtract the n from the start A. So what we want in 1D space, we want, you know, the thing going from 0 to B. We actually want that.
Yeah.
So how do you get that? Well, you can't really get that in 1D space, because that's like you have to do that in 2D space to do the conversion to 1D space.
Right, but I thought, again, how is that not n hat? Like, how are we not just starting at A and like,
well, n hat
hatting the B end to the A, B end minus A start that would be the whole.
N hat is kind of the opposite of what you want, because n hat has been normalized. So this has, the length of that is, you know, 1. It's like n hat equals 1.
Yeah, but I mean to slide. Like I was trying to slide from A to B, and then I would know the length.
Well, we're already doing that. We've already got the n component. We're doing the slide here. So we've got the n. From A, we're sliding along n by whatever B start is. So, you know, you could slide along by like this much and end up here, but you want to slide along by a particular amount, which is that much. So the n hat is already involved. It's doing the sliding when we go to output this thing.
Yeah. So, like, I mean, it's just right. It's right there. I just want the bloody blue line. And it starts at 0 and it ends at B.
Yep. So that would be, that's this vector here. We'll call that S.
Yeah, and then I just subtract this circle B radius to get to the edge of it.
Yep. So all you have to do is figure out where the end of S would be on this number line.
And it's not at B. It's not B.
I mean, it is B, but B is a 2D vector, so you're going to have to convert it somehow.
Multiply it by.
Okay. Okay. Here's what. Here's what we're gonna do. We're basically gonna get the cheat sheet up. These are all of the options that we have. So we're just gonna run through this and see what will help. So you tell me. So what can we do? What can we do with vector addition and subtraction? Like, what can we do to this that would help?
Subtract B from 0.
Well, subtracting something from 0 just gives you the negative.
I know. That's why it's silly, but
not quite. I mean, you're on the right track, because like subtracting B from 0 gives you a vector that's like, you know, this, because keep in mind that B is actually a position in space, so it gives you a vector that's just the negative of B, which is off the page there. But there are other things you could subtract B from.
Well, from the start of from the end of A.
So that's just A. A is this. So subtract B from A. Yes, you get the vector S. So you get from there to there, which is that in theory. But if we were to move it to then the position of A, you get B. So we've basically recreated this diagram here. We have this vector S. That's going to be useful to us. So good. Let's keep going. Vector scaling, is that going to help us in this case?
I forget what we're even doing. We're trying to draw S, right, on the screen.
Well, kind of. We're trying to get S mapped onto this one-dimensional number line. So from 0 to there. So we've already actually got that in 2 dimensions.
Yeah, we want to get it to 1 dimension. Yeah, so we'll scale it by a vector that removes the y component.
Well, that would be the vector
0 or 1,
1,
0.
comma 0.
Yeah, that's like x hat, right?
That's x hat. So, but keep in mind that what you're doing there is S is a vector, X is a vector. You're multiplying 2 vectors together, and that's not the same as vector scaling, and that's not, as I was saying, that's not a useful operation.
Then vector scaling doesn't apply here.
Correct.
I actually want
So next one.
The other thing, or I don't want to normalize it either. So
okay, well ignore that. So vector length is that
length? It has to be the length.
It has to be the length. Okay, so
the length squared or whatever, right?
Well, let's say it's the length for now, because I mean this should make a lot of sense. We want this on a 1D number line. If this is 0 and this is say 1, 2, 3, 4. I know it's not to scale. It's like, what value do you want to get at the other end? You want to get 3. 3 is here. 3 is that is. What's the length of the blue one? What's the length of our vector S? It's 3. It's the thing that's that was a terrible circle, but it's the length of 3. So let's take our newfound knowledge of what that is and take it back to this thing and try and code that up now. So we know how to get to, we could call it float B center. So I'll let you write that code.
I have no idea. B center, like.
So
I was thinking in terms of S. Why do we care about B center? Oh, B center is just.
B center is here. So we've discussed how to get this. We need the vector S and we need its length.
Yeah. So yeah, vector S is just B minus A. And then. Okay.
Cool. Okay. Good start. I mean, and we could test this. We could say plus 0 times that plus. Let's try this now. So we've zeroed that out. So we're going from A to B center. Let's see if this does what we expect it to do. Does this give us B center? That's looking pretty good to me. So you're happy with that diagram?
Yeah.
Cool. Okay, now let's just finish up with B start and B end. So all we have to do now is figure those out.
Well, B end is going to be B center minus circle B radius. No, that's B start actually, isn't it?
Yeah, because we already had that in.
And B end is just going to be B center plus the circle B. There it goes.
Right. Let's let's see what that does.
Oops.
Perfect. So we have our one-dimensional number line, and we have where that is. And if we have circles that overlap, now we can say, oh, look, these two sections overlap, and we can calculate that in one dimension. But I think that is something that we can save for the next one.
Definitely.
I can hear you're fading a bit. I think we've gone quite long. So let's save up and end the recording. See you later, YouTube.